warm greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. In the previous lecture, we have discussed about humidity concepts, importance and measurements. In this lecture, we will be discussing on evaporation and condensation. So, what are all the contents we are going to discuss in this lecture? That is hydrological cycle, water vapor in the atmosphere, process and types of evaporation and condensation, factors affecting evaporation and condensation, and importance of evaporation and condensation. So, these are all the contents we are going to discuss in this lecture. Water cycle. So, water cycle is also known as hydrological cycle. That is, it is a continuous exchange of water. So, between the atmosphere, lithosphere and biosphere. That is, in between the atmosphere, oceans and lands. So, once the land, the surface is heated up, what happens? That is, the evaporation process takes place, and the evaporated water vapor reaches the atmosphere to form the condensation, and condensation in due course it forms the clouds, and then it pours as a rainfall, again it reaches to the earth's surface. So, this was the entire cyclic process of water which have been taken place in this hydrological cycle. That is, a moisture enter air through evaporation, transpiration, that is evaporation and transpiration combinedly known as evapotranspiration. So, these are all the processes in which water cycle, that is hydrological process, takes place. The condensation forms clouds and then it leads to precipitation. The total water remains constant. So, this is the most important thing. The water amount is not changing. The water amount is constant in the entire system, and this hydrological cycle maintain balance between evaporation and precipitation. So, there was a balancing effect in this process. Water vapor in the atmosphere, that is, the water vapor in the atmosphere varies from 0 to 4% by the volume. That is, at the maximum it will be 4%, and averaging it is about 2% of the atmosphere. So, it is about 2% in the atmosphere, and the humidity is measured in the previous lecture. It is measured using various instruments. The common measured instrument is hygrometer. The significance of atmospheric moisture. So, why it is needed? That is, the water vapor absorbs incoming and terrestrial radiation. So, because of the observation, what happens? It plays an important role in Earth's heat budget. So, in the heat budget, atmospheric heat budget, so we have discussed this balancing effect. So, that is maintained in this process. The amount of water vapor determines latent heat stored. The latent is the most important factor. It influences the development of storms and cyclones. So, the storms and cyclones are mainly determined by this atmospheric moisture. The atmospheric moisture affects the human body cooling, and then it also alters what? The sensible temperature. The temperature is felt, whether it is a comfort zone or it is not in a comfort zone, is determined by atmospheric moisture. The next one is evaporation. That is, the ocean covers 71% of the earth. The area coverage of ocean is 71%, and it holds 97% of its water. So, we have various water bodies in the earth's surface. Either it may be in the form of ocean, it may be in the form of sea, or it may be in the form of inland waterways. But altogether, this ocean plays a dominant role, that is, it holds 97% of water. The evapotranspiration begins the hydrological cycle, and the ocean supplies 84%, but the contribution of land is only 16%. See the contribution of ocean in the evaporation process. Because of vast water bodies, it supports the evaporation process. The highest ocean evaporation occurs in subtropical oceans and trade wind zones. It is mainly because of warm currents. The warm ocean current plays an important role in this evaporation of these particular regions. The maximum land evaporation occurs in equatorial region from high insolation and dense vegetation. That is, because of high insolation, it leads to the high evaporation effect. Because of evaporation, the condensation process takes place, and then it leads to the precipitation. So, these processes are interlinked with one another. The next is that the evaporation process is by the water is transformed from liquid to gaseous state. So, what is meant by evaporation? The liquid water is changed into gaseous state. So, this was the concept of evaporation. The heat is the main triggering factor which caused the evaporation. Without the insulation, without the heating process, evaporation could not be happened. That is, the temperature at which the water starts evaporating is referred as latent heat of vaporization. So, this is most important. So, if you are going to boil water in a pan, so it does not vaporize immediately. So, it takes some point to get the vaporization. So, that point of evaporation takes place is known as latent heat of vaporization. Energy involved in evaporation, that is, the energy requires the latent heat of vaporization, that is 2260 kilojoules per kilograms. So, this was the measurement of the latent heat of vaporization. To change for what purpose? That is, it is changing the water into water vapor. In order to change the liquid state into gaseous state, so this amount of latent heat of vaporization is required. The heat is observed. So, here the heat is observed from the sun, that is sunlight, the water surfaces or the surrounding air. So, because of gaining all the heat, what happens? The water molecules here, the water molecules gain energy and it overcomes the intermolecular forces and escapes as the evaporation. So, because of the heat, it is escaping as an evaporation. So, evaporation causes cooling of the surface from which it occurs. So, here once the heat due to the heat energy, the evaporation that is rises up, this region, the surface will be cooled. So, this effect is produced by evaporation. It plays a vital role in regulating local and global energy balance. So, local and global energy balance is maintained or influenced by evaporation. What are all the factors affecting evaporation? Temperature, surface area, humidity, wind and atmospheric pressure are the factors which influences the evaporation. The types of evaporation. So, from where the evaporation takes place, that is, the evaporation is from ocean, lakes and rivers. So, these were all the water bodies where the evaporation process takes place, and soil evaporation is from the moist soil, where there is a humid soil, that soil will be evaporating. And the plant transpiration, that is evapotranspiration, takes place in the crops, especially all the vegetation. And the sublimation is the process which directly solidifies the that is water vapor directly solidifies. So, this process is known as sublimation. It forms the ice or that is snowfall and then haze. So, all these processes happening because of sublimation. The industrial evaporation forms the in the cooling and desalinization process. So, these are all the types of evaporation. Condensation. So, after evaporation, there is another one process, that is condensation. So, condensation is the change of water vapor into liquid. In the evaporation, it was from the liquid to gaseous state, but in the condensation, it is a change of water vapor into liquid state. So, this was the catch here. It occurs due to loss of heat. There in the evaporation, it absorbs the heat. In the condensation, it is losing its heat energy. It lost the heat. That is, it is because of latent heat of condensation. In the evaporation, there is a latent heat of vaporization, but in the condensation, there is a latent heat of condensation. It is opposite to vaporization effect, and the cooling that is a cooling moist air leads to saturation. If it is going to be saturation, the relative humidity is 100%, and the process is the dew point. When it occurs attains the dew point, there is it reaches the 100% of relative humidity. The excess water vapor then condenses into liquid form, and direct change of vapor to solid is called as sublimation. So, in the previous slide we have discussed about the sublimation, that is if it is going to be condensation, the water vapor is changing into what? It is a liquid form, but in the sublimation the water vapor is changing directly into solid form. So, this was the difference, this was the concept here. What are all the process of condensation? That is, the condensation in free air occurs around hygroscopic condensation molecules, that is nuclei. So, the hygroscopic nuclei is nothing but it is a dust, smoke, pollen grains and the sea salt. So, these are all the nuclei which is suspending in the air, which supports, which triggers the process of condensation. It occurs when the moist air cools or touches the colder objects near the dew point. So, if it is going to touch the dew point, so it cools the region, nearby regions. It depends on cooling intensity and relative humidity. So, this condensation process is mainly dependent on two factors, that is cooling intensity and the relative humidity. The conditions for the condensation. What are all the conditions? That is, the condensation occurs when air temperature falls to the dew point. When it drops to the dew point, what happens? With the volume remaining constant. So, the volume is constant. So, whatever the air parcel, the parcel of air is constant, but it reaches the dew point and the temperature is also falling. So, this leads to condensation. It also occurs when both temperature and volume decreases. The temperature and volume decreases, what happens? Or when the moisture added to the evaporation. So, in the evaporation more and more moisture is added, what happens? It leads to the saturation, the saturation point, dew point. So, because of that attaining stages, it leads to the condensation process. After condensation, the atmospheric moisture appears dew, frost, fog or clouds. So, in these forms the condensation process is leading to. Then the condensation occurs in both above and below freezing point. So, condensation can be occurred above the freezing point and below the freezing points also. What are all the factors affecting condensation? That is, cooling of air to dew point causes condensation. This we have already discussed. That is, near 100% of relative humidity speed up the condensation process. That is a triggering for process, and the dust and smoke is one are the most important nuclei, hygroscopic nuclei, which supports the condensation process. It also that is, the rising air cools and it promotes the condensation. So, these are all the favorable conditions for the condensation, and the pressure drop during ascent leads to the condensation. If the pressure is going to drop, it going to be lower, what happen? It leads to condensation. So, these are all the favorable factor which determine the condensation. Forms of condensation. There are a number of forms of condensation, that is, the forms of condensation can be classified on the basis of temperature. That is, temperature is most important here, at which the dew point is reached. So, when the temperature reached the saturation level, that is a dew point, this condensation process takes place. The condensation takes place when the dew point in two cases, that is case 1, it is lower than the freezing point, and case 2 is the higher than the freezing point. So, we have already discussed that the freezing point can be done in above the level and below the freezing point level also. So, if it is going to be a lower than freezing point, so this is a freezing point. If it is going to be lower the freezing point, what are all the forms of condensation? That is white frost, snow, some clouds like cirrus clouds forms due to this lowering effect. And if it is going to be above the freezing point, so what happens? That is, the liquid state will be there here. In this state, liquid state will be there, that is the dew, fog and clouds are the result of higher the if it is going to be higher in the higher than the freezing point. So, this was the major difference. If it is going to be higher, it will be in the form of dew, fog and clouds. What are all the types of condensation? They are dew. The dew is nothing but it is a condensation on the surface during the night times, and if it is going to be a fog, it is a condensation near the ground. So, the near the ground we can witness the fog situation, fog condition, and frost is a condensation that freezes, it solidifies. And if it is going to be a clouds, what happened? The condensation at the higher altitude, you can witness the clouds. And in the industrial condensation, it is used in the streams and then distillation processes. In the industry also, this condensation takes place. So, these are all the different types of condensation. First and foremost is dew. So, the dew is nothing but it is a moisture deposited in the form of water droplets. So, you can see here there is a water droplets in the grass. So, rather than the nuclei in the air, usually what happens if the evaporation takes place, the warm air rises up and it will be suspending in the air higher altitudes, but here what happens? It is found in the surface of the earth. Where it is found, that is in the stones, grass blades and plant leaves, you can witness this dew formation. And it is ideal condition when it is formed. What are the favorable conditions in which this dew can form? That is, if the condition is clear skies are there, and if it is a calm air and high relative humidity and cold and long nights. So, these are all the favorable condition which supports to form this dew. And for the formation of dew, it is necessary for the dew point above the freezing point. So, in the earlier conditions we have discussed this one. So, the dew point should be above the freezing point. Next one is frost. The frost on the cold surfaces when the condition takes place below the freezing point. There in the dew it is above the freezing point, in the frost it is below the freezing point, that is 0 degrees Celsius. Then the excess of moisture is deposited in the form of minute ice crystals instead of water droplet. If it is going to be frost, it is solidified, the content is solidified. So, it is in the form of minute ice crystals. The ideal condition for the formation of white frost are same as that of dew, that is the formation of dew, except the air temperature must be at or below the freezing point. So, all the other condition is same as of the dew formation. Only thing which changes is that the air temperature should be below the freezing point. There it is above the freezing point. The next formation is fog. That is when the temperature of an air masses containing large quantity of water vapor falls of a sudden condensation which takes place within itself on a fine dust particles. The fog is nothing but it is similar to the cloud formation. But it is not exactly cloud. The cloud will be a thicker in state, but this fog is somewhat not much thicker. It is a thin, but it will be that is nearby the surface. This foggy condition will be nearby the surface. The hygroscopic nuclei will be suspended in the air nearby the surface of the earth, and then condensation takes place, and then the fog formation will be occur in that particular place. So, it is because of the fog and mist, the visibility will be very poor. So, if there is a foggy state in a region, what will be there? It affects the visibility. Here you must know what is meant by frontal or precipitation fog. That is, it produces by warm and cold air masses, where warm air masses is pushed under the heavier cold air masses. So, this warm and cold air, because it is a frontal. So, this term we know it is a border of warm and cold air. So, because of this situation, this precipitation fog occurs in that particular place. The precipitation fogs, that is the warm air masses condenses to produce fog at the boundary of two air masses. These are called as a frontal or precipitation fog. Next one is mist. So, often we confuse with the mist and fog. It is more or less similar, but what difference we will be discussing in this one? The difference between the mist and fog is that mist contains more moisture than fog. So, the moisture is high in the mist. So, this is the main difference between the mist and fog. In the mist, each nuclei, that is the hygroscopic nuclei, contain a thicker layer of moisture. The mist are frequent over mountain. So, in the mountainous region, you can see this kind of mist weather phenomena, whereas the rising warm air up the slope meets the cold surfaces. So, this was the condition in which the mist is formed. The fogs are drier than mist. So, this is also one of the important differentiation. They are prevalent where the warm current of the air comes in contact with the cold current. So, the warm and cold current, when it meets, this kind of weather phenomena occurs, that is mist. In mist, the visibility is also affected like fog, but to which extent, that is more than 1 kilometer, but less than 2 kilometer. So, this was the condition of mist. Then haze. So, we will be discussing while we converse that today is a hazy situation. So, what is meant by haze? That is, haze is a traditionally an atmospheric phenomena where dust, smoke and other dry particles are there. This kind of hazy situation can be observed in the metropolitan sites. That is, source of haze particles includes forming like ploughing in the dry weather and traffic, that is vehicle fumes, industrial emissions and wildfires. Forest fire are the most contributed for this haze situation. The next weather condition is smog. The smog is a smoke plus fog. So, this two combines to form a smog condition, weather phenomena. It is caused by the burning of large amount of coal, vehicular emission and industrial fumes, that is primary pollutant. It is also similar to haze. So, this was the favorable condition or the factors which triggers the smog condition in that particular region. The importance of evaporation, that is the evaporation, it supplies the water vapor in the atmosphere, and due to that the clouds are formed and precipitation is also occurred in that particular region because of water vaporization, that is evaporation. It drives the hydrological cycle and moving the water from the surface to atmosphere. So, this entire cycle is mainly triggered or driven by the evaporation process. The cool surface by observing heat, regulating the local temperature. It also, the evaporation also controls the humidity amount and also influences the weather pattern and climatic pattern of the entire region. It also supports the agriculture, water management and energy balance in global scale. Importance of condensation. The precipitation replenishes the lake, rivers and groundwater. So, because of precipitation, it recharges the local water bodies. It releases the latent heat. It also energizes the storms, cyclones and convectional currents. So, and it also one of the important factor, because of condensation process, what happens, it leads to the precipitation. It may be in various forms, it may be in the dew or it may be in the fog or it may be in the frost weather phenomena. And it is also balancing the atmospheric energy and it also influences the climatic patterns. It supports not only the atmosphere and surface temperature or precipitation, it also supports the ecosystem and agricultural pattern of a place by supplying the water resources. Evaporation and climate, that is a hot dry climate having high evaporation and low humidity. Vice versa, that is in the desert region, the evaporation exceeds the precipitation, which is creating the arid condition. That is in the hot dry climates, that is the tropical region, it experiences the high evaporation which is leading to the high precipitation, that is heavy rainfall, and it makes the region much more humid. The evaporation influences the air pressure, driving the monsoon and wind pattern. So, it also affects the biomes and ecosystem of the entire globe. Condensation and climate, that is, the cloud formation regulates the solar radiation, which causes the cooling and warming effect. So, it is a balance, the condensation is the balance between cooling and warming effect. The precipitation depends on condensation rates, which is influencing the wet or dry climate of that particular zone. The high condensation leads to intense storm, thunderstorm and cyclone. So, that if there is an intensification of condensation, it leads to the adverse climatic condition, weather patterns. The low condensation results in arid region with clear sky. Imagine the anticyclonic process, what happens. So, that is explained here. It impacts the regional and local micro level climates. So, because of this condensation, it not only affects globally, it also affects the microclimate of that particular locality. To sum up with the entire lecture, the evaporation is a process by which liquid water changes into vapor, and by what? By latent heat, while condensation is a reverse process where water vapor changes to liquid state by releasing the again latent heat that absorbs here release. Together these processes forms as a core for hydrological cycle, regulating the humidity of a place and cloud formation, rainfall of that particular place, and also the temperature determination. It plays a vital role in driving weather system, maintaining the climatic balances, and also transfers the energy within the atmosphere. So, I hope you understand this evaporation and condensation process. In the upcoming lecture, we will be discussing on cloud formation. Thank you.